only see some part, the partially survived. Most of the first line seawall was collapsed. And this survived part is because of the gate. This is a gate that connecting the inland with the outside. Okay, let me stop my talk. And yeah, this picture was taken by myself. Yeah, when I was undergraduate student of this university, and my graduation thesis study was on tsunami. And actually, I myself made a field trip to Taro and take this picture. And this is a gate connecting the full 10-meter seawall connecting the inland to the seaside. But as I explained, this picture, which I last week, only this part survived. The total, whole seawall has been crushed, collapsed. And we started to analyze, or we started to understand, we started to try to understand what this event is. And this picture is one effort that shows distribution of tsunami inundation height, starting from Aomori to the Chiba village. And the comparison between the historic event, the blue one, Meiji, yellow Showa, and the green is Chi, and red is Tohoku. Yeah, this event. And you may understand that we have maximum inundation height around the middle. And you may also understand that the red one is the biggest, largest tsunami in the 150 years. And we are just discussing how to restore the seawalls, design tsunami height of seawalls. And we are looking at this event is composed of two types of tsunami, which is the Sanriku tsunami, which repeated with the 100 years and produced the large inundation height, especially in the Sanriku district. But this event is superimposed by the other Jogan type, the huge tsunami affecting the relatively wide area, but the repetition, the return period of the Jogan type tsunami is much larger than the Sanriku tsunami. So by this kind of analysis, we expect that we can decide the reasonable design height, considering the return period of the event. Okay, so let me wrap up my talk. We are still under analysis of the inundation height or tsunami model. But if I try to explain this event at this moment, I can say that this event produced a very huge tsunami, especially in the Sanriku coast. And this event was larger than Meiji and the Showa, so the largest in the 150 years. And this tsunami is characterized by which attacked the very wide area, and those areas was subsided before the tsunami attack. And because the epicenter was close to the land, so they arrived in relatively short time. And the return period can be considered once in 100 years for the Sanriku event, but the Sanriku event was superimposed by the very rare event of Jogan type 100,000 years. And the last point is the damages are very huge, and it affected also the very flat plain that are formed around the rivers. Tsunami, as I mentioned in the first slide, was considered to affect the harbor area. But this tsunami affected not only the port and harbors, but also the flat plains. So this event is very strange tsunami in the sense that they affected not only the two parts. Okay, that's all.
We have 5 minutes. We can take questions. If someone is interested to ask a question, she is welcome. Any question related to tsunami, generation of tsunami, phenomena of tsunami, anything related to tsunami?
Can I ask you a question about the previous lecture? Yeah. I remember there was a picture about a seawall underwater. How high was that seawall? Yeah. In the base of the breakwater.
Underwater, actually the breakwater was
Yes, the breakwater.
is construct the water depth, the original water depth was 60 or 60 meters. Then we made the gravels, we made the water depth 30 meters. Then the caisson was placed 30 meters.
That means half of the height was covered up.
Since you mentioned that the scale of this tsunami is about 1,000 years, so while designing some protection measures, what type of, you can say, the strategies are under consideration while we consider 1,000 years of tsunami?
Okay, we are proposing that we don't take the very rare event as a design condition for structures. So the structures should be designed for the event of return period within 100 years. So over that level that we propose to evacuate. That is a very, say, rough strategy. Structure will cover the frequent, but evacuation will be important for the very rare event, once in 1,000 years.
Do you think that there was some articles talking about how some of these protection walls fail? So do you think that the fact that you have a wall in your town gives you a false sense of security? So maybe you say, we have a wall that protects it for 100 years event, so I don't evacuate. Instead, I should be evacuating for any kind of event because you don't know, for example, this was unexpected. So doesn't that break wall give the residents a false sense of security?
You mean the security after the evacuation?
After the earthquake happens, the tsunami comes, right? But some people may think that because there is a big wall that was designed according to engineering standards, they might think it's safe to stay instead of evacuating.
Okay, yeah, I understand that some people overestimated the function of the seawalls. So that is a very sad thing. But we have to evacuate. We have to educate those people that during the tsunami event, it's hard to predict the tsunami height very accurately. So we have to evacuate ourselves, even if the warning estimation tsunami height is smaller or lower than the height of the seawall. But some people over predicted the function of seawall.
Can we go back to one of your last slides with the coast and the height distribution of the waves?
Oh, yeah.
So it seems to be some protected area in the middle. What's the reason of the protection?
Oh, yeah, this area?
Yeah.
Yeah, Fukushima.
Oh, really?
That's all. Okay, we cannot go inside.
So, is there any effect of the age of the shape of the island? Because you said that if the shape, like the ledge shape, the height of the wave reach the harbor will be very high. If the edge of the island is flat shape, how is the height of the wave reach the harbor? Is there any relation with the edge of the island shape?
Okay, I will explain something. That if the shape of the land is convex to the sea, that means more likely the bathymetry contour lines of the sea depths will be also convex to the sea. That will influence the concentration of tsunami by the lengthening. Okay, and you are talking about what happens if the shape of the land is flat, right? It depends on the bathymetry. Okay? And of course, it depends on the slope of the bathymetry. If you have very deep flat boundary, then the tsunami will be totally reflected by the particle. So the amplification will be only double. However, if the slope of the beach is defined, then by the window that Ima-sensei explained, you have to understand that in some cases the amplification will be more than 10 times.